second video for the Chapter 2 notes. So this is starting at the top of page 5. And the first type of graph that we have is called a Pareto chart. It says in a bar graph whose bars are drawn in descending order or frequencies of relative frequencies, the bars are going to decrease in heights from left to right. The next type of graph that we have is called a pie chart. I feel like most of us have seen a pie chart somewhere along the line, either in the news or reading any type of article. And so this is a circle divided into sections. Each section represents a category of data. The area for each sector or section is proportional to the frequency or percent of the category. So the example right below says the table below shows the most common cosmetic surgeries for women in 2024. A total of 1.35 million procedures were performed on women in 2024. Sources given in Part A says how many surgeries are not accounted for, and you can see that in that table there is an other category that does not have that number given. So first thing is it tells us that we have 1.35 million surgeries total. And so what this is as a number, not written with the word million in there, is going to be 1,350,000. And so this is 1.35 mil. And you do not need to put the commas in when you're using any type of online program, such as the StatDisk that we'll be using for our projects, or if you're using a calculator or a graphing calculator. So do not put those commas in. So first thing is that we have how many women had breast augmentation, lipo, eyelid surgery, nose reshaping, and a tummy tuck given. And in order to figure out that other category that we're missing, we're going to have to subtract those numbers from the 1.35 mil. When you do this, you get 338,000 surgeries that are in that other category. So again, 338,000. So Part B says to create a pie chart representing the cosmetic plastic surgeries that women had in 2024. So the first thing that we need is we need to draw a circle. So do your best on this one. And we're going to cut up this circle into sections, and each section or sector is going to correspond to that percent that we have, the amount of people that have had that type of surgery. So in order to do this, we need to actually calculate our relative frequencies. And so if you remember from relative frequencies, this is going to be where you take the frequency for each class and divide by that total. And remember, the total is the 1.35 mil. So for breast augmentation, we're going to take 312,000 on your calculator and divide that by 1350000, that 1.35 mil. When you do this, I'm going to go ahead and round just 2 decimal places. You get 0.23. For the liposuction category, we have 284,000, and we're going to divide that by the 1.35 mil. And when you do this, you get 0.21. Next, we're going to do eyelid surgery, which is the 150,000 divided by the 1.35 mil, and we get 0.11. For nose reshaping, again, dividing the 138,000 by the 1.35 mil, and we get 0.10. Tummy tuck, when dividing the 128,000 divided by the 1.35 mil, you get 0.09. And then that last category of other, 338,000 divided by the 1.35 mil, this works out to being 0.25. You can convert these to percents. Some students find it easier. I am going to leave them as relative frequencies. We mostly deal with decimals in this class and not percentages. So the easiest one to draw on here is going to be that other category. You can put it anywhere that you want. So I'm going to go ahead and just cut this into a quarter so that other category is 0.25. So you need to label it with what the category is, along with the percent that it has, or that decimal that we're using. Next one that I'm going to go ahead and do is going to be breast augmentation. I'm going to abbreviate this one, BA. And this is almost the same percentage. It's 0.23. So we're just going to go a little bit less. And I'm going to call this again BA for breast augmentation, and that's 0.23. The next one I'm going to look at is liposuction, which is even just a little bit smaller. And it does not matter where you place these in your circle, just as long as you label them and then also put those decimals. The last three that we have are 0.11, 0.10, and 0.09, very similar in size. So I'm going to go ahead and split my remaining part up. The largest one that I have looks like this bottom one, just how I drew it. And this is going to be eyelid surgery. And so I'll put down eyelid. And this is 0.11. And then we have 0.10, which is going to be nose reshaping. So we'll call that nose, and that's 0.110. And then 0.09 is tummy tuck. I'm going to abbreviate that one TT for tummy tuck. And this is 0.09. If you added up all these percents, or decimals in our case, you should get 1, which is what you would like. The only thing that we have is that there's no axes here, but you do need to give this graph a title. And so this is 2024 plastic surgeries on women. So this is our pie chart. The next thing that we have is called a frequency polygon and also a relative frequency polygon. And these are very similar. And so when we're talking about these, I'm going to go ahead and draw 2 graphs, so make sure to include these in on your notes also for each of these. And so a frequency polygon is a graph that uses points connected by line segments to represent the frequencies of the class. And it's constructed by using class midpoints at a height that's corresponding to the frequency. So we're going to have frequency and we're going to have midpoints here. And remember, we talked about midpoints earlier, and that's where you're going to add those 2 values and divide by 2. The next one, relative frequency polygon, is a graph that uses points connecting line segments to represent the relative frequencies of the classes. It's constructed by using class midpoints at a height equal to the relative frequencies. So this is going to use relative frequencies and also midpoints. So for both of these, we are going to add a little bit of information in here. Give this 2 stars, and this is going to correspond to both the relative frequency polygon and also our frequency polygon that we had up above. And so the difference here is you're not just going to have your points and connect those with straight lines. You're also going to have to extend. Make sure to add this to your notes also. Extend your ends of your graph on left and right. Sides. So graph starts and ends on the horizontal line. And it also says up above that the frequency polygon provides the same information as a histogram. Next information that we have is going to be group data. This is formed by putting individual observations of a variable into groups, usually with a lower class limit and an upper class limit. So to graph our group data, we need to calculate the midpoints of each class. And so this is a big part for us. And so calculating midpoints again is found by adding. So adding up your lower class limit and your upper class limit and then dividing by 2. So you need to add the lower class limit and the upper class limit and dividing that answer by 2. Well, at the top of the next page says monthly rain totals in inches are represented in the table below. Construct a frequency polygon of the data. You'll notice that we have grouped data here. The first class is 2.01 to 2.75. Second class is 2.76 to 3.50 and so forth. And so in order to find our midpoints, which we need in order to do our polygon, we need to add together the lower class limit and the upper class limit and then divide by 2. So the first midpoint is going to be adding together 2.01 plus 2.75, getting a result, and then dividing that by 2. And our answer is going to be 2.38. The second class, we'd add together 2.76 plus 3.50, get a result, and then divide that by 2, and we get 3.13. The third class is 3.51 plus 4.25, get a result, divide by 2. We get 3.88. And then following that same pattern of adding the lower class limit and the upper class limit for the last 3 classes and dividing it by 2 is going to give us 4.63, 5.38, and 6.13. So in order to construct our frequency polygon, we need to have 2 axes on here. And the horizontal axis is going to be our midpoints, and the vertical axis is going to be our frequencies. So let's look at frequency first. If it said relative frequency polygon, then we would have had to calculate those relative frequencies, but this one's only asking about frequency polygon. So the frequencies, the smallest number we have is a 1, and it goes all the way up to 11, so I'm just going to count by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then on the horizontal axes, we need to put down our midpoints. There's a little catch here. So the first thing is we're going to just put a dash first. We'll fill that number in a moment. And then I'm going to put down the other remaining midpoints. So we have 2.38, 3.13, 3.88, 4.63, 5.38, and 6.13. I'm also going to put one more little dash here that we'll talk about after we do the plotting of the points and connecting them. I need to label my axes, and this is talking about the data that we have given, and this is going to be our monthly rain totals. So this is monthly rain totals, and it's given in inches. And so starting off and plotting our midpoints and frequencies that correspond to them, the first one at 2.38, we have a frequency of 5. At 3.13, we have a frequency of 11. And I'm going to connect those 2 points with a straight line. The next midpoint is 3.88 with a frequency of 9. Again, connecting those 2 consecutive points with a straight line. At 4.63, frequency is 4. At 5.38, the frequency is 3. And then at 6.13, the frequency that we have there is just 1. And so again, connecting those consecutive points with a straight line. So if you remember, the thing that we added to our notes is that we are going to extend our graph on both sides down to the horizontal axes, so at the end and also at the beginning. And so what we need to calculate now is these 2 values here, because we don't have numbers and we're going to need those. And so in order to go from one class to the next, we need our class width. And the class width is where you would subtract a lower class limit minus the previous consecutive class limit. And so we have 2.76 minus 2.01, and we get 0.75. And so in order to calculate these, remember we are using the midpoints, and since we are going with a class width of 0.75, that is how you go between each of these numbers on our midpoints. So be adding 0.75 to each of these to get the next one. And so to get the last midpoint that we need to add, I'm going to take 6.13 and add my class width, which is 0.75. Doing this, I get 6.88. And that's the value that's going to go on the last part that we have on our graph. And then in order to get the previous one, instead of adding 0.75, we're going to subtract it. So I'm going to take 2.38 minus 0.75 since it's previous. Doing this, I get 1.63, and that's the number that's going to go in here. And so this is our frequency polygon. Make sure that you've labeled both your axes, and you also have extended your graphs down to include those last little pieces to touch our horizontal axes, and included both these numbers and how to calculate them. The example right below this is very similar. This one says monthly rain totals in inches are represented in the table. Construct a frequency histogram of the data. And you'll notice that the data is identical. And remember that a histogram is where our bars are going to touch one another. And so again, for this, we will need midpoints since we are dealing with that grouped data. And I'm just going to copy down the midpoints that we've already calculated from up above. And so we have 2.38, 3.13, 3.88, 4.63, 5.38, and 6.13. From here, we need to put on our two axes, just like we did up above. The vertical one, again, is going to be our frequency, since it is asking about a frequency histogram. And I'm going to count by just ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm just labeling those. And then I'm going to put my midpoints on. I want you to notice that we are doing a histogram and not a polygon, so we do not have lines that need to be extended down. So I just need to put on the midpoints that we have here, which are going to be 2.38, 3.13, 3.88, 4.63, 5.38, and 6.13. Likewise, I need to label my axes, and this again is our monthly rain total measured in inches. So you don't want to make sure you label this midpoints because that doesn't describe what the data represents. You want to make sure that you use the words that are talking about the actual data that were being collected, which is in this case monthly rain totals in inches. So from here, I'm going to draw my bars. My bars are going to touch one another from each consecutive group in class. So our first frequency with a midpoint of 2.38 is 5. So we'll draw our bar up and over and back down. 3.13 goes all the way up to 11. You want to try to make your bars equal width. It is difficult to do by hand, but try the best that you can. 3.88 has a frequency of 9. 4.63 has a frequency of 4. Our next midpoint of 5.38 has a frequency of 3. And then our last one has a frequency of 1. So what do you notice about the two graphs above? And I'm going to go ahead and zoom out here a little bit just so we can see them both. And if you notice, if I were to take the midpoints and put points and connect them with lines, and extend those lines down, you would have identical graphs. So these are very similar. And so on the next page, we have another example. This one says data in the table represents the number of U.S. residents aged 25 to 74 who have earned a bachelor's degree. Construct a relative frequency polygon this time. So instead we're constructing a relative frequency polygon. You'll notice that we still have our grouped data. So the first group is 25 to 34, so that's our first class. So we do need to calculate our midpoints first. And so calculating our midpoints, 25 plus 34, and then dividing by 2. So you would get 59 divided by 2 is going to be 29.5. Adding together 35 plus 44, dividing by 2, we get 39.5. And so forth with the rest of the classes, 49.5, 59.5, 69.5. It's easy to see a pattern on this one. Since we're asked to do our relative frequencies, we need to calculate those also since we do not have those. So we're going to make another column that's for relative frequency. And remember, relative frequency, you need to take the frequency for each class and divide by the total. So we do need to calculate the total, and in order to do that, you need to add up all of the numbers that we have here. And so if you add up the total frequency that we would have is going to be 54,817. And so dividing our first class frequency, which is 12,967, divided by that total, 54,817, I'm going to go ahead and round 2 decimal places, and I get 0.24. Likewise, for the next class, it's taking 13,904 divided by the 54,817, and we get 0.25. Continuing this on, I get 0.24, 0.19, and 0.08. So we're going to go ahead and put our 2 axes on in order to do my polygon. And this time, instead of frequencies, it's asking for a relative frequency. And so the relative frequency, if you notice here, our relative frequencies are going from 0.08 to the largest is 0.25. So I'm going to count by 0.05. So we have 0.05, 0.10, 0.15, 0.20, and 0.25. You can count any way that you would like just to get up to that total value that's the highest for the relative frequencies, which is 0.25. Likewise, since this is a polygon, we're going to start with one little dash and not label it yet. And then from here, we're going to put on the remaining midpoints. So we have 29.5, 39.5, 49.5, 59.5, 69.5, and then again, one remaining dash. These two values we will get, but this will be at the end. And I'll circle them right there just so we don't forget to do that. I need to make sure to label this, and this is talking about the ages that people are that have a bachelor's degree. So we're going to say ages. And so with this, graphing our points, so with a midpoint of 29.5, we have 0.24. 39.5, we have 0.25. Connecting those 2 points with a straight line. 49.5, we get 0.24 again, and connecting with another straight line. And then we have, for the next midpoint, 0.19. And connecting those 2 consecutive points with a straight line. And then for 0.25, 0.08, that's occurring at 69.5. Connecting those 2 points together with a straight line. And then this is going to extend down and extending our graph down to the horizontal line on both the start and the end. So in order to do this, we need to have our class width. And so class width is going to be 35 minus 25, which is just 10. And so in order to get our very last midpoint that we would put in there, we're going to take 69.5 and add 10 to it. And so we get 79.5. And some of you guys just might see the pattern and not even have to do any of the math. And then previous, remember, we're subtracting. So we have 29.5 minus 10, and we get 19.5. So this is the graph of our relative frequency polygon. Again, make sure that you have labeled your axes. In addition, you have also extended the ends of your graph down, included these numbers at the ends. Next, right below this, we have graphs that may be misleading, and the most common misrepresentation of data involves scales of graphs as an inconsistent scale or misplacing the origin. So the first example that we have says the graph below showed the same data represented two different ways. How is the first graph misleading? So it looks like a drastic drop here between the three different groups that we have, when in fact, if you look at the percentages, they're not that far off. And so this is an accurate representing, and this one is misleading. This one is misleading because it does not, axis is not starting at 0. And so it skews everything to make it look incorrect. The last example here says, how is the graph misleading? Does the graph accurately illustrate the data? And so if you notice it, it says Michael, it looks like, has a lot more than the other student. And so with this is because Michael has twice, if you look at how tall those candy corns are, so twice as much candy. But since the widths are also increasing, it looks like more. So you want to make sure your bars, it's candy corn in this representation, but your widths of those bars that you would use would be equal, and those heights just correspond to the frequency. So this is our chapter 2 notes. Together, the first video plus the second video have completed all of the chapter 2 notes. From here, you need to make sure that you upload your notes as a single PDF file, and please reach out through email or office hours if you have any questions.